Okay, guys, so today we're going to do rates of change from word problems. Okay, we've already done a little bit of word problems all throughout, but we're going to go over it a little bit more to see how it works. Okay, and the big thing is this is the last of all of our different kinds of rates of change from different things. So we did tables, graphs, equations, and word problems. And then in the next 2 days, we're going to mix them all together and try to work with them all mixed together. Okay, so just like any other word problem, you want to underline your keywords. And really important words are per, each, and every, or things that look like that could mean the same thing, okay? And then circle our number. So and then write the equation. Okay, so let's read this example right here. An artist is making a scale model of a statue. On the model, 2 inches represents 1 foot. So every time you see a number, you should be circling it or writing it down. Like those are the numbers I need to use on the actual statue. Which graph best represents this relationship? So I don't have any graphs, but I'm just using this to help you out. So this one, you don't see per, each, or every there, but I see this word, represents. Okay, represents is going to be something that works as well. So if I have 2 inches on the model, that means it's going to equal 1 foot on the actual statue. Okay, so I could say 2 inches for every 1 foot, and that would be the same. Okay, so what I would do is remember 2. I'm always going to write it as a fraction over, because that says represents, and it's just like per, each, or every 1. Okay, and that would end up being my rate of change. So the rate of change is going to be 2. You could still write the equation if you want. It would be y equals 2x. But if you can just divide it out, then you can do that as well. So my equation would end up being y equals 2x. That was a horrible 2. Okay, so, and remember, rate of change is just the number. It's not going to be have the x with it, so it's just going to be the 2 in this case. Okay, let me erase this, and then we'll move on. And I only have one other example for you because it's pretty simple. Ooh. Okay. A dolphin travels through the water at a speed of 25 kilometers. 25 kilometers. So that's my number. Per, so per means that's where we put the fraction bar, right? Hour. And that just says hour. That means it's just 1 hour, right? So we just want a 1 there. Which representation shows the distance a dolphin can travel at this rate? Okay, and this is a little example of mixing them all together. So this is a word problem that we have to read and understand what the rate of change is, and then we have to match it to one of these specific things. So we've got some words, we've got equations, we've got a table, we've got a graph. So word problem, table, equation, graph, okay? So let's see, that says 25 per hour, which means my rate of change would be 25 over 1, which anything divided by 1 is always itself. Okay, so we're looking for the one that matches 25. Okay, so let's see. In 5 hours, a dolphin can travel a distance of 135 kilometers. Okay, so let's think about that. If the dolphin can travel 25 kilometers in 1 hour, okay, then after 5 hours, how much is it going to travel? Okay, so every hour he's traveling 25, which means after 5 hours, I need to do 25 times 5. 25 times 5, right? 5 times 5 is 25. 5 times 2 is 10, 12. That's 125. So it's not that one because that says 135. Okay, and then remember to find rate of change on a table. We number them 1, 2, 1, 2. Okay, and we're going to do y2. So x is always our first column here. X is always our first column. Y is always our second column. So we're going to do 50, because that's y2, minus 0, that's y1, over x2, that's 2, minus 0, because that's x1. And then we do 50. So 50 minus 0 is 50. And 2 minus 0 is 2. And then 50 divided by 2. What's half of 50? 25. Is that the number we were looking for? Yes, it is. That's what we were looking for, okay? So I'm pretty sure it's this one, but let's go check the other ones. C, y equals x plus 25, where x represents the time in hours and y represents the distance in kilometers. So remember what I told you about equations. The rate of change, which is 25 over here, is always going to be attached to the x, okay? And since the 25 is not with the x, we know it's not that one, okay? And then our graphs, okay? It should be 25 for every hour, okay? So this, if we look, it's important to look at our labels on graphs because this says hours down here. And this says kilometers, okay? So what this is saying is for every 25 hours, they only go 1 kilometer. Is that right? No, because we want 25 kilometers per hour. So we would want to have kilometers on the bottom instead of hours, or these hours need to be 1 hour and then that needs to be 25. So our numbers need to be switched here. So it's not going to be D. So we were right. It is B. Okay. And if you're confident that that was it, then you don't have to go through all of them. But I wanted to show you and make sure you understood why the other ones were wrong. Okay. If you have any questions, you know how to get a hold of me, email, comments, whatever. Just realize that sometimes I may not get to you right away, so you might have to be a little patient, go do some other work for another class, and then come back and I might have answered it, okay? Because I try to answer it as quick as possible. And then tomorrow we're mixing them all together and you're just doing work, okay? And on Friday, don't forget, please remember, on Friday you're going to be taking a CBA. So you're going to be testing on Friday, and I want to make sure that you are ready for that, okay? So your work on Thursday is going to be a little bit of a review of everything we've learned so far, okay? And if you want extra practice on that stuff, then let me know and I'll find you something to help you practice everything, okay? You guys have a great day. Bye.